What is I2C? Just tell what you know about that. It's need not to be always accurate. Just tell what you know about this I2C. Anyone?
It's a
Mohammed.
two-wire communication protocol.
Okay, it's a two-wire communication protocol. Good. Then
For serial communication purpose.
okay, it's in serial communication. It's a
Protocol.
two-wire. Okay, so it is in serial communication. Okay, and it is also called as a two-wire communication.
Clock and data, I guess.
Okay. What type of connections will be there apart from the wiring? How you will connect the multiple devices? UART is a peer-to-peer communication. Okay, and your SPI is a master-slave communication. That is a single master multi-slave communication. What is I2C?
Multi-master, multi-slave communication.
Okay, so it is a multi-master multi-slave communication. Okay, so I just compare all these three communication protocol over here. First, we will start with the UART. So UART is an okay. So when you are attending an interview, if they ask about this UART or SPI or I2C, you just have to tell something in an order. Okay, or let's make it as something like a continuation explanation. Okay, so UART is an asynchronous mode of communication. Okay, and it has two wires. One is TX and RX. Okay, and here we will be having or here this TX and RX devices will be connected in the peer-to-peer communication. That is, one device will connect with another device. That's it. And since it is an asynchronous mode, we don't have any clock pulse. So we need to use something called as a baud rate to determine the data transferring speed. Okay, so that is in baud rate. So baud rate will be varying from this 1200, 1400, 4900, all these things that you can explain. Okay, and similarly for our SPI protocol, SPI is in synchronous communication. Okay, it requires 4 wires. These are serial clock, MISO, MOSI, and we have this SS, slave select, RCS, chip select. Okay, and then the communication or connections over here is it is a single master multi-slave. Okay, so this is the order you need to tell whenever you are explaining any communication protocol. Okay, so similarly, your I2C is an serial communication. All these are serial communications only. Okay, you just need to tell it is an synchronous mode of serial communication. Okay, your I2C is a synchronous mode of serial communication. It has two wires. The two wires are serial clock and serial data. Okay, we have SCK and SDA. Okay, so SCK is in serial clock and SDA is in serial data. So we have only 2 pins that is enough to communicate with each other. So it is serial data. And also you need to know where we need to use any of this protocol. Okay, for example, what you'll be using when there is only one device has to transfer with another device. Okay, then you can directly go for this UART. It requires less number of wires, and the communication transferring rate is very simple. It has only TX RX. You just have to connect this RX to TX, TX to RX. That's it. Okay. Since it is an asynchronous communication, it doesn't have any clock pulse and all these things will not matter. Okay, but if you want to transfer to multiple devices, okay, and that multiple devices will mostly transfer a data to a single device. Okay, for example, you have a microprocessor or microcontroller, all your sensors and your memories has to transfer the data to this microprocessor or microcontroller. Okay, let's assume like that. Then you need to go for the SPI protocol. Since SPI is as a single master and multiple slaves, you can keep all these sensors, the memories, okay, as a slave, and you can keep this microcontroller as a master. Okay, then you can go for this SPI communication. Okay, so it isn't single master multi-slave, but if you want to communicate with more number of devices at a time, that means one device has to receive as well as transfer to one or more device, then you can go for this I2C communication. Okay, this is again in synchronous communication, but it is a multi-master multi-slave. You can have multiple masters and you can have a multiple slaves in a single network. Okay, so depends on the application and usage, you can decide which communication mode you need to use. Okay, and in our next class we will see the CAN protocol also, and where we need to use this CAN protocol, all these things we will explain there. Okay, but as of now, these three are your common communication protocols. Okay, so your CAN protocol is not available in all the microcontrollers board. Like nowadays, most of the microcontroller board is having a CAN, but still we'll be using only these three protocols very often, right? Okay, so I'll just draw these. The connection of this. Okay, let's make this is one device, and this is another device. Okay, and we have one more device over here. And we have another device. Okay, let's assume we have three devices. Okay, now I'm just going to call this as an master one. Okay, and this one as master two. And this one as slave one, slave two, and slave three. Okay, and for our understanding, okay, just make this master one as, we will just make it as a microcontroller. Okay, for example, this master one is nothing but your microcontroller, and this master two is your memory, that is EEPROM. Okay, or flash, whatever it is, just make it as a flash memory or EEPROM memory. And your slave ones are first one, it is, let's assume it's a some sensor. Okay, and second slave device, let's make it as an OLED device. Okay, so that is your display device. Okay, and third one, we have a sensor, we have OLED device, this is memory. Okay, this, let's say this is another sensor. Let's make it sensor one and sensor two. Okay, now I just need to transfer the data from the sensor to microcontroller. Okay, and this microcontroller has to send the data to the slave for displaying, and again the slave has to send the data to this microcontroller. Also the slave has to transfer the data to EEPROM for saving the memory data, and the slave also 3 also needs to send the data to this EEPROM. Okay, this is what my connection is. So this has to connect with this one first and this one. Okay, there are multiple connections available, right? So we required more number of wires if it is connected to peer-to-peer communication. Okay, and also it requires much complex coding for transferring the data from one device to another device. Okay, instead of that, we will go for, there is something called as the I2C communication. Okay, so in I2C communication, we'll be having a two wires. So we'll be having two different wires. So first one is your serial data. Okay. Okay. And SDA serial data, and this is nothing but serial clock. I have only two pin. So these two pins are enough to transfer a data to multiple devices. Okay. Now this master one will connect with okay. So this master one will connect with the serial data as well as it will connect with the serial clock. Okay. And similarly, your slave will also connect with your serial clock and serial data. Okay. And similarly, EEPROM will also connect with this and this. This will also connect with this and this. And this will also connect with this and this. Okay. So each and every device is connected with only the same common serial data and serial clock wire. Okay. Now this serial data and serial clock wire, it has to be terminated with, let's say your device is going to transfer the data, right? So these data are nothing but it is an 5 voltage data. Okay. So you need to terminate this with a ground pin. Okay. Which is connected to a resistor. Okay. So this is your R1 and this is your R2. Right. So this is how your I2C connection looks like. So I2C connection has to be always terminated with the ground that is connected parallelly to the resistors. Okay. Now, if my sensor one has to transfer the data to the master one. Okay. So it will transfer the data. It will transfer the data from, let's assume this is your serial data, right? So this serial data will connect over here. And from here, this serial data will transfer. Okay. This is how the connection will be. But there is another problem. Since this wire, this single serial data wire is connected with this master, this slave, and this slave. Okay. This is nothing but an electrical signal, right? So this electrical signal can pass through all these devices. Okay. The same problem occurs in our SPI. But what we did in SPI is we have something called as a slave select or a chip select. Okay. This particular pin is going to determine which slave I need to select to data transfer. Okay. That I can able to give in the SPI. I can able to make it as a logical 0 in order to select that particular slave device. Okay. That is possible in the SPI. But here we don't have any such kind of slave select devices or slave select pins over here. Okay. We have only two pin data and clock. So how to differ or how to transfer to that particular device here is we have something called as an address mode. Okay, so this I2C is an address based data transfer or address based communication. Okay, each and every device, even your CAN protocol is also an address based one only. Okay, so that we will see in the next class. But this I2C is an address-based communication. The address-based communication is nothing but each and every device you are connecting in the I2C is having an unique address. Okay. So for example, let's assume your microcontroller is having something like in 0x03. Okay. And your EEPROM is having something like in 0x65. And this one is something like in 0x 30, and this is something like in 0x68. Okay, and this is something like in 0x95, something like this. Okay, we can give and unique address for each and every devices. Okay. Now, for example, if your device 0x30 has to transfer its sensor data to the 0x30, okay, it will first send an request to the 0x30. Okay. Now what will happen? Okay, in this case, this is a master, right? Okay. Now what will happen? This master will send a data request, okay, to this slave device initially. Okay, send the data to me, like that it will ask. Now what will happen once it receives this data request signal? It will send an acknowledgement signal back to this microcontroller. Okay, and then it will transfer the data to this microcontroller. Once all the data is received, this microcontroller, that is your master device, will again send an acknowledgement signal back to slave in order to tell, okay, my data transfer is completed. Okay, so this is what will happen in the I2C. I'll write it over here. First, your master will send a signal, okay, to the slave. We call this as a data request. Okay. Now what will happen? Your slave will reply back with an acknowledgement. Once this acknowledgement has received, okay, then the data, next data will be transferred from the slave to this master. Okay. Once all the data is finished, okay, this is the data. Once all the data is finished, then this will send another acknowledgement signal back to the slave in order to denote, okay, I have received all the data. So now we can stop communicating. Something like that will happen. Okay, so this is what and simple I2C communication method. Okay. Now, similarly, if the master has to transfer the data to the slave, the same thing. So master has to tell the slave that I'm going to send some data. Okay, so this is an request. Okay, now the slave, if it is free, then it will send an acknowledgement back to the master. Okay, I'm ready to receive the data. Now what will happen? The master will send the data back to the slave. Okay, and then once the data has been sent, then the acknowledgement transfer signal will be received. Okay, so this is for transferring a data from master to slave, and this is for requesting a data from the slave. Both this decision has to be taken by the master. Okay, that's why it is called as a master. So master has to tell whether it is going to receive the data or whether it's going to transfer the data from which device it's need to tell. Okay, so this request will contain the particular address of that device. Okay, and also there will be an acknowledgement signal, stop bit signal, and data signal. All these things will be there. We call that as a frame format. Okay, we saw that frame format in the UART, right? Similarly, I2C is having a frame formats for data transfer. Okay, so this is what an I2C communication is. Okay, is it clear so far? Any doubts? Or if
Clear,
it
sir.
is
Resistor elixir is no. Why we are using the resistor?
this resistor. Okay, actually we need to what to say, terminate this. Okay. Let's assume I am having an LED. Okay, this is my anode, this is my cathode, right? Here I am giving an 5 voltage. Will this LED will glow?
No.
Why?
Ground connection.
Okay, so I need to connect with a ground. Okay, so either I need to limit the current over here with the ground so that the circuit will be complete in order to send some signal to this LED. Okay, so this is my LED, right? Similarly, here your data are nothing but it is a plus 5 voltage signal. Okay, that is the I pulses. Okay, from the master to slave or slave to master, we will be transferring the I signals. Okay, in order to close this circuit, we will be connecting it to ground with a resistor. Okay.
Mm.
Is it clear? Or do you still have a doubt?
Yes, sir.
Okay. You can actually define this with which data you are going to transfer. Okay. For example, here your high pulses are data and low pulses are zeros, right? For example, if you want to transfer 101100, okay, this will be high, this will be low, this will high, low, low. Okay, this is how this connection will be there. Okay, for example, if you want to transfer in the open drain method, okay, then you can actually make this as a plus 5 volt. Now here the zero signals are your signals. Okay, one are your grounds. You can actually able to change the pulses like how you did with the push button. Okay, whether you are going to connect with an drain open drain
Pull up,
method or pull
pull
up or
down
pull
and
down method. Okay, same thing. Okay, you can able to define it with this uh, ground and 5 volt. Okay.
okay.
Yeah. Yes. So this, any other doubts? No. Okay. Now here we have something like in five different devices, right? Okay, so you can actually able to connect some n number of devices. The maximum limit of devices you can able to connect it's an 120 0 to is okay, it's an 128 devices you can able to connect in the I2C. Actually, it is 127. That will be 128, right? Okay, so we can able to connect up to 127 devices. Okay, so I will tell you why this 127 is. So this 127 device, it can be any number of masters, any number of slave devices. Okay, it need not to be always something like a master has to be more and slave has to be less, or master has to be less and slave has to be more, not like that. You can actually able to connect 126 master device and one slave device also. Okay, so that is possible because we can actually able to transfer the data between master to master. Okay, so that is also possible here. So we can able to connect up to 127 different devices in the I2C. Okay, now we will see the frame format, like how we are going to transfer the data. Okay, so the next is frame format. As like your USART, here we will be having and frame format, how many data we are going to transfer and all these things. Okay, so first, as like your UART, the first bit is your start bit. Okay, I'll just draw one box, a lengthy box. Okay, here the first bit is your data bit. Sorry, first bit is your start bit. Okay, as like the same USART, this will be your start bit. Okay, so after start bit, what will happen is we will be having an 8 different bit modes will be there. Okay, so 1, 2, 3, 4, 5, 6, 7, and this is 8. Okay, So 1, 2, 3, 4, 5, 6, 7. Okay. So we have 8 different bits. After that, we call this as an 7-bit address mode and 1 bit of read write mode. Okay. So this is an 7-bit address mode. That is from this to this, it is an address mode. Okay. So your address value will be start with A0 to A6. So 7-bit address. So this is your okay. This is your A0, A1, A2, A3, A4, A5, and A6. Okay, so we have 7-bit of address mode.
So this
So
address, sir, this address is dedicated for this, especially for this on memory mapping.
for this one, like which device you are going to transfer.
Okay, okay.
Okay, for example, if it is 0x30, you need to mention that over here.
Slave one.
Yeah, no, not slave. It can be from, for example, if you want to transfer the data, it is 0x03, right? So 0x03 has to be here.
Okay.
Okay, so which device you are going to transfer the data, that address has to be here.
Okay.
Okay, so 2 power 7, which is nothing but 127. So that is why we can able to connect up to 127 different devices in the I2C. Okay, so start with 00000002 up to 1111111. So this much amount of devices you can able to connect. That is this much amount of different addresses you can able to assign in the I2C, so that we can able to transfer up to 127 different addresses or devices. Okay, so that is what this 127 is. So we have a 7-bit of address, and the next bit is your r/w bar. Okay, so this is your read write bit. Okay, so if your r/w bar, if you set this particular bit as 1, or if you set this particular bit as 0. Okay, there are two different ways. If you set this as 1, that means you are going to read from this particular address. Okay, or if you set it as a 0, you are going to write to that particular address. Okay, that you need to define over here, whether you are going to read the data or whether you are going to write the data. For example, like our previous example, if the master has to send a request to the slave to read the sensor data, then here it will set as an 1 for reading this sensor data. Okay, so it has to send the data over here to request, okay, I'm going to read your sensor data, something like that. Okay, so whether we are going to read the data, and if the sensor has to reply back to the master, then it is going to write it. Okay, so that particular bit will be 0 for writing. Okay, so we can able to define whether we are going to read the data or whether we are going to write the data in this particular bit. Okay, clear so far?
Yes, sir.
Okay. Yeah, so next, after that, for example, let's say this master is requesting, okay, this master is requesting a data to the slave for read mode. Okay, so this address has been set, and I need to read it. That also we have set it over here. Okay, now this slave has to respond back, right? Okay, I'm ready to transfer the data. Okay, so that readiness will be given in this next bit. We call this as an acknowledgement bit. Okay, so once this device is ready to transfer a data, then it will send an acknowledgement signal back. Okay, so after that, we will be having an 8 different data bits. 1, 2, 3, 4, 5, 6, 6, 7, and 8. Okay. Okay, so we are having 8 different bits. Okay, that is specifically for the data transfer. So start with D0, D1, D2, D3, D4, D. Okay, I need one more. Just a minute. Mm. Just make it 3. 3, 4, 6, 7. Okay, so we'll be having 8 different data bits. Start with this is D0, D1, D2, D3, D4, D5, D6, and D7. Okay, so we are going to transfer in 8 different data. Okay, as like how this address will be acknowledged. Okay, once this data has been received or write, okay, that is read or write, after that we'll need to give an acknowledgement signal. Okay, so this is nothing but RACK acknowledge. Okay, one acknowledgement is for this address bit and another acknowledgement is for the data transmission. Okay, after this it will be and stop bit. Okay, so this is an address and similarly this one is for data bits. Okay, so this is what and frame format for the I2C. Okay, so we have a start bit to stop bit. Inside that we'll be having an 7 bit of address, one read write bit, one acknowledgement bit, then again 8 bit of data and one acknowledgement bit at the last and then a stop bit. Okay, so this is what and frame format for I2C. Any doubts? Is that clear? Or do you have any doubts?
Yes.
Okay, others? If you have any doubt, just let me know. The reason I'm explaining this much of theory is like it is one of the most important concept in any microcontroller, this communication protocols. Okay, you need to know what is happening. It is just as simple a single line of code. Okay, so if I go to this AL programming in my STM, we'll just write this entire thing in a single line. Okay, but in on background you just need to know what is happening, how this data has been transferred and all these things you need to know. Okay, so that's there's I2C theory. If you have any doubts anywhere, just let me know. I will explain it again, or we will just go back to the coding. Shall I go to the code?
Sir,
Yeah.
this is two wires, no? So how it look like if you want to connect multiple devices, like two master, three slaves. So
So
how
this
they?
is how there will be a single STA and single SCK. Okay, we can
No,
just
in
tap it.
physical, how it look like?
Yeah, we can just tap it wherever you want this SD and SC. Okay. Yes, Ajmal.
Yeah, always 8-bit தான் transfer, sir. Whatever microcontroller, 32-bit or 8-bit.
புரியல.
என்ன மைக்ரோ கண்ட்ரோலர் 8 பிட் தான் ட்ரான்ஸ்ஃபர்
இந்த டேட்டாவா? ஆமா, டேட்டா எப்பவுமே நம்ம கேரக்டரா தான் அனுப்புவோம். ஓகேவா? ஸோ கேரக்டர் எப்பவுமே 8 பிட்ஸ் தானே. ஒவ்வொரு 8 பிட்டா தான் அனுப்புவோம் எப்பவுமே. We can't actually able to transfer the number in any communication protocol. அது கொஞ்சம் கஷ்டம். ஓகே, நம்ம அது எப்பவுமே கேரக்டர் தான் அனுப்புவோம்.
STM32 32-bit அது.
32 பிட் தான். ஆனால் ஒரு கேரக்டர் வந்து நமக்கு 8 பிட் தானே. இப்போ ஃபார் எக்ஸாம்பிள் இப்போ ஹெல்லோ அப்படின்னு இருக்குன்னு வச்சுப்போம். ஓகே, இந்த ஹெல்லோவை நீங்கள் ட்ரான்ஸ்ஃபர் பண்ண போறீங்கன்னா ஹெச்ன்றது 8 பிட் கரெக்டா? இது ஒரு சிங்கிள் கேரக்டர், இது 8 பிட். ஓகே, நெக்ஸ்ட் இது ஒரு 8 பிட், நெக்ஸ்ட் இது ஒரு 8 பிட். ஸோ எந்த கேரக்டர் எடுத்தாலுமே அது மேக்ஸிமம் 8 பிட் தான் இருக்க போகுது. அதனால தான் மோஸ்ட் ஆஃப் த கம்யூனிகேஷன் ப்ரோட்டோகால்ஸில் அது 8 பிட் டேட்டா ட்ரான்ஸ்ஃபர் தான் ஃபிக்ஸ்டாக இருக்கும். ஈவன் தோ இட் இஸ் 32 பிட் ஆர் 64 பிட். நம்ம பிட் பை பிட் தான் அனுப்புகிறோம். ஓகே, சிங்க்ரனஸ் கம்யூனிகேஷன் ஆர் சீரியல் கம்யூனிகேஷனில் பிட் பை பிட் தான் அனுப்புகிறோன்றதுனால அது அப்படி தான் இருக்கும் எப்பவுமே.
Okay.
These are all ASCII, sir. ASCII
Yeah,
or
ASCII.
string?
ASCII.
ASCII. So that's why 7-bit. 0 to
8 bit 0 to 7. Yeah, this H
Okay.
is actually converted into an ASCII with a specific hexadecimal number. Let's say your
yes,
A
sir,
is
yes,
65,
sir. That
right?
yeah, 65. That is
So that will be converted into an 8 bit.
okay. Sir.
Yeah. Okay. So here we will see two different programs in I2C. First program, we will see how to get a I2C value or I2C address. Okay, we need to know which address I need to transfer, right? Okay, for example, if you're collecting multiple devices, you need to know which device has a particular address. Okay, this I2C address is usually given in the data sheet. You can refer any sensor, any I2C based sensor, that I2C address is given over there. For example, let's say I'll just open here with okay, let's say I'm just going to connect an OLED. This is 0.96 inch OLED display data sheet. Okay, so this actually this works on the I2C communication only, your OLED display. Okay, we will just see the okay. So here you can see it is an I2C based communication. If you go to this data sheet, you will find the address. Okay, these are dimensions. Pin configuration. Okay, I'll just search it as an EDDRE. Okay. Yes. Top 56 continuity MCU I2C communication. Okay, so you can see this is for the address range. Okay, for transferring the data, right? And this is lower address and higher address. Memory address, column address, and all this. Okay, so this 20H is your memory address. Okay, that is an hexadecimal number 0x20. You need to transfer for this particular OLED display module. Okay, so similarly for any IT device you take, it has an memory address. Okay, I'll just show you one more example. Let's take what else you have with the I2C. Okay, let's say your air pressure sensor or BMP, this 280. I think it works in the I2C. Yeah, this one looks. Yeah, it is work in the I2C up to this megahertz, and if you want to use, you can use it as in the SPI also. Yeah, so that it can actually work with two different modes. And just search the address over here. You will find the address of this particular I2C also. Okay, so you can see this 8-bit registers start with the 0x88. Okay, for transferring the data up to this 0x90. Okay, so this like first digital temperature value. Okay, up to like how many data values you need. All this data registers address will be given here. Okay, so for any data transfer for this I2C, you need an this data sheet. Okay, for data transferring. Or if you don't have this data sheet, we can write a program to find a simple program for finding the address of any I2C device. Okay, so that we will first write. Okay, so before that, I will just show you the configuration for this I2C pin. Okay, so first, as usual, select your particular microcontroller board. I'm going to select my STM32F334. Okay, so this is my I2C underscore hardware. Just open. The UC file is not created. File new STM32. Okay, this one. Next, I'll just give I2C hardware 1. I logged in over here. Why this project type?
Sir, I am also facing same issue.
You're also facing same issue.
It's not
I am
opening.
also. It is
Mm.
updating actually some files.
Oh, okay. So that's why I didn't get one.
For me, it's updating many files.
Okay, okay. But it is not updating for me actually.
சார் இல்ல சாயந்தரம் நான் கிரியேட் பண்ணேன் சார். இதே ப்ராப்ளம் அந்த ஐஓசி கிரியேட் ஆகும்.
இதே ப்ராப்ளம் தான் வந்துச்சா?
ஆமா சார், சாயந்தரம் ஒரு 5 மணி இருக்கும். அப்போ ஓப்பன் பண்ணப்போ ஒரு ஃபைல் கிரியேட் பண்ணேன். ஸோ ஐஓசி மட்டும் வரவே இல்லை சார். வேற
Okay.
வேற போர்டு செலக்ட் பண்ணா நிறைய ப்ராப்ளம்.
இல்ல ஆக்சுவலா இங்க வந்து டார்கெட் ப்ராஜெக்ட் டைப்னு இருக்கு இல்லையா? You have to select this as an STM32 cube. If it is selected as empty, it will not open this IOC file. It has to select it to STM cube, but it is not actually selecting. Okay, no issues. I will just open my previous project and I will explain you that concept. Okay, this is my I2C class. Let me check this. Yeah, okay. So once this problem is rectified, you just try this one. Okay. Yeah. So here what you need to do is, as usual, just go to system core and this RCC. Okay, just select this clock source. Okay, that is first step. And second step, go to this connectivity. And here we have something called as an I2C. Okay, click this I2C. Select this I2C over here. Okay, it will be disabled initially. You just have to select it as an I2C. And in that, there is some parameter settings. Okay. In this parameter settings, we'll be having a different speed mode. Okay. I'll just tell you what are the speed modes is. You can actually able to use this SPI for multiple data transferring speed. Okay, that is possible with this SPI, I2C. Okay. So first one we have an standard mode. I'll just write it over here. So first one we have a standard mode. So in standard mode, it is actually 100 kilobits per second. Okay, you can actually able to transfer the data in this particular speed. Okay, and then we have something called as a fast mode. So in fast mode, you will be having 400 kilobits per second. Okay, and we have something called as a fast mode plus or fast mode pro, something like that will be there. Okay, so that is you can able to transfer up to 1 megabits per second. Okay, so these are the most commonly used 3 different speed modes. Apart from that, some advanced board is having an high speed mode. Okay, so this high speed mode is having something like a 3 to 4 megabits per second of data transferring can be done. Okay, so depends on your application, how much data you need to transfer. You can select either one of this mode, either a standard mode, fast mode, or fast mode plus or high speed mode. Okay, only this high speed mode is not available for all the boards. It is specifically for a particular boards only. Okay. So here the speed mode is the I2C speed mode. Okay, so you just click, you can see we have a fast mode, standard mode, and fast mode plus. And in some boards, we'll be having this high speed mode also. Okay, so select this mode, and this is a speed frequency. You can see the maximum speed is 1 to 100, and if you select in fast mode, it will be varying from 1 to 400. Someone's mic is unmute. Venkateshwar, can you just unmute yourself? Yeah. So you can see if I select the fast mode, this can be vary from 1 to 400. Okay, on the bottom you can see over it here. And if you select in fast mode plus, you can actually able to select from this 1 megabits. Okay, so 1 to 1000, that is 1 megabits. So depends on which mode you are selecting, this speed will vary. Okay, so this is an 100 kilohertz speed, and rise time make it as a 0. It can be varying from 0 to 1000, and fall time is also, it can be vary from 0 to 300. You can set it anything. And this is a timing mode. This timing mode will be generated differently for each and every time you are creating it. Okay, so this is on timing mode. We just need to change only these two, standard mode and this frequency. That's it. Okay, so you just leave everything else as it is. And we have a 7-bit address mode. That is fine. And this slave mode address, okay, you can see it over here. It ranges from 0 to 127. Okay, if you want to connect it to specific slave, or let's say your device is a slave device, then you need to set some address over here. Then you can set it over. For example, if you want to set an slave device, you can just set it 50. Okay, now this primary slave address will be 50. Okay, so that you can able to do. You just give it a 0 over here, and everything else is same. Okay, so just once generate this code, you'll get a code. Okay, like this. So since I already wrote this code once, so I'm just telling you what it is. I'm having this handler type. Okay, this previous handler. And this is for UART, which is previously defined. Okay, I'm just creating one variable called as A. Okay, so in this A, I'm just going to transfer this particular string high. Okay, now I'm just going directly to this main function. Okay, these are your system generated, like your I2C initialization, UART initialization, GPI initialization, everything is a system defined. Okay, here you need to give something called as an AL I2C initialization. Here we are going to use this AL based I2C initialization of this particular handler. Okay. Here I have only one I2C. That means it is only I2C1. If you are having a multiple I2Cs over there in your particular board, for example, this 446 board is having 3 I2Cs, I think so. And this discovery board is also having something like 2 or 3 different I2Cs over there. Okay, you can select any one I2Cs, depends on what you are going to use. Okay, that particular handler has to be given here for initialization. After this is what your AL transfer is. Okay, I'll just type multiple things for you. One is AL I2C for master transfer or transmit. Okay, this is one. And similarly, we'll be having a master receive. Okay, so first I'll just type and transmit and tell you what are the things you need to give. Okay, inside this master transmit, it just needs to tell through which handler I need to transfer. Okay, this is my I2C1 handler, and which device address I need to transfer this data to. Okay, for example, your device address is something like a 50 or a 30 or a 80, whatever it is. For example, in my case, if it is 30, I'll be giving 30 over here. Okay, this is the device address you are going to transfer. And the next one is the data. Which data you are going to transfer? I'm going to transfer the data A in us 8 bits. Okay, so I'm just going to give something like an unsigned int 8_t of this A. Okay, after this, I just need to give what is the size you are going to transfer. This is like your UART, as like how you define everything, same thing. And this timeout is, I'm just giving 100 millisecond. Okay, so this is for transmitting a data. Okay, similarly, if you want to receive a data, just give al underscore I2C underscore. If it is a master, just give master underscore receive. Okay, here it will ask the same thing. So through which handler I need to receive and from which address I need to receive. Okay, for example, if you want to receive from something like an 80, just give 80 and where I need to store this data. Okay, if you want to store something like an buffer value, just give u int 8_t of this rx buffer. Sorry, rx buffer. Okay, any variable you can just define it and you can give this. Okay, and the size is size of that same variable. I'm just giving rx buff. Okay, and after that, this timeout is again, I'm just giving something like an 100 for transferring the data over here. Okay, so for this rx buffer, I just need to declare this rx buffer over here, something like the a. Okay, so this is my let's say this is my character rx buffer of, I'm just going to receive this high, right? So I'm just giving a 3. Okay, so this is for transferring a data. This is for receiving a data as a master. Okay, similarly, you can do this as a slave also. Okay, same thing, hal underscore I2C underscore slave underscore transmit. Okay, so like for slave transmit, the same thing like this one. And here you don't have this particular address because anyhow your master is going to request you. So you know that master address, right? Okay, so slave doesn't have an ability to choose which address I need to transfer. Okay, only this master has to request a data to the slave, then slave has to transfer that particular data back to the master. Okay, for that particular communication to be happen. For example, here I'm just asking the permission to transfer the data, right? Then the slave has to transfer the data to this particular device. Okay, so we don't have any device address in this slave transmission. Then what is the data you need to transfer, and what is the size of the data? What is the timeout? Same thing. Okay, and similarly for the receive also, I2C underscore slave underscore receive. Okay, here again, which handler, where I need to receive and store the data, what is the size of the data, what is the timeout, all these things I need to give. Okay, so we'll be using only these 4 different APIs for transmitting as a master, receiving as a master, transmitting as a slave, and receiving as a slave. Okay, so apart from these 4, you will be using this AL initialization for I2C. That's it. Okay, so this is what your I2C data transferring is. Okay, clear?
One doubt, sir. So
Yeah.
if master is a transmit, which means it is asking for the seeking for the transmit request. So slave will transmit
Yeah.
and master will receive it for like a
Okay.
request. Then
Actually, the order has to be something like this.
okay.
Okay. So master will transmit, then the slave will transmit it back. During that time, master will receive. Actually, this program you have to give in some other board, that slave board.
Okay.
Okay. So this is your master board program. This is your slave board program. Like what I have written it over here, the same thing on the right side. Okay. Yeah. So this is the API for the I2C communication. Okay, it's very simple. If you can have multiple boards, one board can be configured as a master, one board can be configured as a slave, and you can just give a particular data, okay, to transfer this device. Okay, so that is possible. Okay, this is for data transfer. Okay, so if you want, just copy this one. Start from, I'll just delete this. This is not needed. Okay. So this one you need to give, and then these things. Okay, that's it. Okay. So copy this, and then we will see the next program, that is how to find the address of the I2C device. Okay, that we will see the next program. Let me know once you finished.
Sir,
So can you
can you able to see the output?
Actually, I don't have any I2C sensor as of now. Yeah. If possible, I will connect with a DST sensor tomorrow or day after tomorrow. Okay. And I will show you the output.
so can you show the I2C configurations on audio set?
Configurations. Okay.
Because for me it looks something different for the slave. That's
Okay. Okay. Yes.
IOC open ಆಗಲ್ಲ sir.
ஆகுதா?
ಆಗಲ್ಲ.
ஆகலையா? சரி,
எனக்கு
okay.
ஆகுது சார்.
உங்களுக்கு ஆகுதா?
நான் ரீபூட் பண்ணி பார்த்தேன் அப்பவும் ஆகல சார்.
ஓகே ஓகே. தெரியல என்ன இஷ்யூ. என்ன வெர்ஷன் யூஸ் பண்றீங்க யாரு?
சார்.
Just go to this help and find this about.
Yes. One dot 18.1.
18. Okay.
Yes, sir.
I'm using 16. Others? Yorach?
One minute. Let me check.
Okay. I'll just update it. Install new software. Software system. Sites.
One dot 10.1 sir.
10. Okay, I think it is working for the newer version. Even I'm having a 16 older version only. Just update it to the latest 1.18 version and then check it. Sorry. Is this visible?
சார் அந்த இது போயிடுச்சு சார். நேம் வரும்ல இல்லை சார்.
என்ன நேம்?
ஸோ ஹலோ பிரசன்னா வந்து இல்லை நேம் வரும்.
ஓகே ஓகே.
அதுவே வரல.
ஓகே.
ஸோ இன்ஸ்டால் நியூ சாஃப்ட்வேர் கொடுத்து என்ன சார் பண்ணோம்?
இங்க கிளிக் பண்ணி either select all available sites கொடுங்க, அப்படி இல்லைனா இந்த அப்டேட் மட்டும் லேட்டஸ்ட் ரிலீஸ் அப்டேட் மட்டும் கொடுத்து ஆட்னு கொடுத்தீங்கன்னா அது ஆட்டோமேட்டிக்காக வந்துடும்.
ரிலீஸ் 2022-03 அதுவா சார்?
ஆமாம்,
லேட்டஸ்டே கொடுக்குறேன்.
லேட்டஸ்ட் வெர்ஷன். I will select this one.
செலக்ட் ஆலா?
ஒரே நிமிஷம். ஆமாம், செலக்ட் ஆல். So be having this session. It will download and install. We'll see that.
Sir,
Yes, Mohammed.
suppose if I have one board and one code is there already, is it
Okay.
possible to check that code? What is there? What code it is?
You are already downloaded that in the board.
Yes.
No, actually you can't able to do that. Because that code will not be in the user readable format in your board. Okay. That will be converted into something else. So you can't able to retrieve it. Even if you retrieve it back from the flash memory, you can't able to understand what it is written.
Okay.
Yeah. And there are some softwares available for converting this assembly code into an human language, but I don't know how much reliable it is.
Okay.
Yeah. Yes, Ajmi.
ஃப்ரீக்வன்சி ஸ்பீடு வந்து அந்த 4 மோட டிபெண்ட் பண்ணுவாங்க சார் ஸ்டாண்டர்ட் மோடு
ஆமா 4 மோட் டிஃபைன் பண்ணி தான் இருக்கும்.
மேக்ஸிமம் 400
மேக்ஸிமம் 400
கிலோஹெர்ட்ஸ்.
அது வந்து இந்த மோடுக்கு செகண்ட் மோட் ஃபாஸ்ட் மோடுக்கு. ஃபாஸ்ட் மோட் ப்ளஸ் கொடுத்தீங்கன்னா 1 மெகாபிட்ஸ் வரைக்கும் யூஸ் பண்ணலாம்.
ஃப்ரீக்வன்சி
ஃப்ரீக்வன்சி தான் சொல்கிறேன். ஃப்ரீக்வன்சி 1 மெகாபிட்ஸ் per செகண்ட் வரைக்கும் கொடுக்கும் இந்த இடத்துல.
ஓகே
1000 கிலோஹெர்ட்ஸ் கொடுக்கலாம். 1000 கிலோஹெர்ட்ஸ்னா 1 மெகாஹெர்ட்ஸ் தானே.
ஓகே சார்.
Sir, I have one doubt.
Yeah.
We can able to communicate with the 2 microcontroller at a time, right?
Yes.
Through I2C.
Yes.
If I connect it to the same computer, I can able to configure both of them.
Yeah, you can configure.
But the device will be connecting to any one to the software, right?
Yes. Okay. The thing is, once you write the program or once you download the program to that particular microcontroller,
Okay.
it will be running. Okay. It just requires a 5 voltage supply through this USB in order to on.
Okay.
Okay. So connect the board which you are going to see the output in your PC.
Okay.
Okay. And then click debug and open it. So your debug monitor will be open for that particular board, right? Whichever board you are going to see the output. After that, connect this particular board which you record only the power supply.
Okay. So that I need
so
to
that it will
connect
transfer the
to
data.
Outer supply, power supply.
Yes, yes,
anything.
power supply.
USB
Either a power supply or this USB also. Yeah.
Okay, sir. Sir, அது முடிஞ்சிட்டு ST link upgrade and
Okay, just click to upgrade.
refresh device list.
Okay, click it.
I think இது வேறன்னு நினைக்கிறேன். எஸ்டி லிங்க் நம்ம யூஸ் பண்றது இல்ல சார்.
எஸ்டி லிங்க் நம்மளோட போர்ட்லயே இருக்கு டிஃபால்ட்டா.
ஓகே.
போர்டு கனெக்ட் பண்ணிட்டு அப்கிரேட் கொடுக்க போதும்.
அது ஆக்சுவலா அது பேக்ரவுண்ட்ல ரன் ஆயிட்டு தான் இருக்கு. இது வேற ஒரு பிளாக்
வேற ஒரு
தனியா
அப்டேட்டா? ஓகே.
ஆமா. சார் கேன் புரோட்டோகால் பண்ணும்போது நமக்கு அந்த அந்த டிவைஸ் வேணுமா சார் கேன் பண்றதுக்கு?
ஆமா, கேன் கன்வெர்ட்டர் வேணும். 2515 கன்வெர்ட்டர்.
நீங்க அப்படியே பண்ணி காட்டுவீங்களா சார்?
புரியல.
என்கிட்ட டிவைஸ் இல்ல அதான் சார்.
என்கிட்ட இல்ல.
ஓகே. ஆனா
காமிக்கிறேன்.
போர்ட்ல அவுட்புட் பார்க்கலாங்க.
லாஜிக் அனலைசர் இருக்குல்ல உங்ககிட்ட,
இருக்கு.
அதுல பார்க்க முடியும் ஆக்சுவலா.
ஓகே. பட் நத்திங் டிஃபரெண்ட்ல. அதுல இருந்து கனெக்ஷன் மட்டும் தானே மாறும், வேற ஒண்ணும் இல்லை.
வேற எதுவும் இல்ல.
அந்த கனெக்டர் வந்து யூஎஸ்பிக்கு யூஸ் ஆகுமா இல்ல அதை வச்சு இன்னொரு டிவைஸ் கனெக்ட் பண்ணுமா?
அதை வச்சு இன்னொரு டிவைஸ் கனெக்ட் பண்றதுக்கு. யூஎஸ்பி கிடையாது அது.
ஓகே ஓகே.
இன்னொரு டிவைஸ் கூட கம்யூனிகேட் பண்றதுக்கு வில் பி யூசிங் திஸ் 2515.
ஓகே சார்.
So can you show the programs and
Okay. Yeah.
private?
So first, just declare this one. That's it. Okay. And then this code, this initialization, and then this.
Okay. Oh, 1 minute. Can you show the private variable?
Private variable. Okay. This.
Or expert. Okay.
Yeah.
சார் இந்த சேம் இதுக்கு பேர் மெட்டல் கோடிங் எழுதணுமா சார்?
எழுதலாம் ஆக்சுவலா.
பட் ஆனா ரொம்ப இதுமே போகணும். இல்ல இந்த 4 பாராமீட்டர்ஸ் மட்டுமே இருந்தா போதுமா இல்ல வேற ஏதாவது கான்ஃபிகர் பண்ணுமா?
இதுல பேர் மெட்டல்லையா?
பேர் மெட்டல்ல.
பேர் மெட்டல் நம்ம நிறைய கான்ஃபிகர் பண்ணணும்.
Sir, அதில் தான் ஒரு டவுட் எனக்கு. Like for I2C we have that is, take example, master is transmitting means, so we need to send a master address also. So already default address has configured, mapped already for the I2C. So how we will get to know? Is there any register for
that's
that?
what I said. Like for any device which you are going to communicate, that device has an I2C address.
Memory mapping. Yeah.
Okay. So just go to this one. You will be getting an I2C address for that. Okay. So this is either a 076 or
no, I'm saying here the STM32. STM32 board.
Okay, from one STM32 board to another STM32 board.
No, sir. Somehow STM board we are connected to some other external devices, but STM has to transmit his ID, right? I2C address.
Yeah, that is this address. For example, if you want to connect with this sensor, just give the 0x76.
Okay, that is a receiver address. So we don't worry about no. Master ka.
master address. If you want to change the master address, just go over there and select it over here. That's it. There is no need to select, worry about this master address, because anyhow, we are not going to select which master I'm going to transfer, right? Master is the one who is going to
Only one
request the data. So we don't need this master address.
Okay.
Sir, one doubt, sir. So, if we are communicating with a different slaves, right? So,
Yeah.
if some, for example, like a battery management system or something like that, each cell is having the different slave address, right?
Yeah. Yes.
So,
Yes.
so if something like one cell is going to be drained out, so directly it will send the address to the master, or each time the master need to be
each time the master has to ask the data.
Okay.
Okay, because slave doesn't have any address to be transferred. You can see over here, it doesn't have any addresses. Okay, so only the master has to request a slave to transfer a data, then the slave will transfer. That is how it will be.
And one more thing, this, for example, we have the different parameters of data, right? For example, like voltage, current, and other state of health like that it is having. So all the three parameters will be under this uint8 underscore star a, like that. There is only one data we are sending here.
See, any data which is transferring in this I2C or SPI or UART, it is transferring a bit by bit.
Okay.
Right?
Okay.
That is what in serial communication, right? We are transferring it in bit by bit. Okay. So as per the frame format of both I2C and UART, you will be transferring or packed 8 bit of data with the start bit and stop bit.
Yes.
Okay. Even you have a 32 bit of data, that 32 bit of data will be segmented into 4 8 bits and packed with start bit and stop bit.
Yeah.
Okay. So once you receive the data and you can store it in some variable, let's say, if you have a 32 bit of data, you can just directly give this one as a 4. Okay. And you can store 0, 1, 2, 3. So that will be, and 4 8 bits of data, right? So that will be 32 bit of data.
Okay. What I'm saying is, like RX buffer is a 132-bit data. I have a 332-bit data means.
This RX buffer is an 8 bit of data.
No. Just an example I'm telling.
If I give this as an 4,
3 different 32-bit data.
Okay. I'll just give in one same example. For example, if you want to check an voltage, just give BMS underscore volt. Okay, there is an 32 bit of data, right? So if it is an 4 array, 4 into 8, 32 bit. Correct?
Yes.
Okay, similarly, one is BMS current. Okay, let's say it is only 16 bit of data. Then just give 2.
Okay. So in that receiving part, what we need to do?
Yeah, in receiving part, here you will be giving that size of, right?
Yes.
Okay, this size of will define how much data will be received. If it is 16 bit of data, it will receive 16 bit and store in this RX buffer. Or in other words, I'll tell you, it will be in the same loop, this receive loop, until it reaches 16 bit.
Okay. And like for example, RX buffer is there, right? So I have created two variables, voltage and current. So I need to write two different variables here
Yes,
for
for
the
receiving. Yes, for receiving.
yes.
Okay. So here you need to give something like in BMS underscore voltage. Okay. And the size is also this BMS underscore voltage. That is 32-bit.
Okay.
Okay. So it will receive 32-bit in a single line.
Okay.
Okay.
For current.
For current, again, you just need to give one more receive.
Oh, okay. So
Okay.
each time we
And then
need for
ah,
every data we need to give each
yes. So
for
that's what
every
I
variables.
shown you this example. For example, okay, this take this data sheet. Mm, yeah, you can see first digit is start with this address.
Okay.
Okay, and second digit is this address. Third one is this address. Fourth one is this address. Okay, so similarly in your BMS, this voltage will be in that particular address. Current will be in that particular address. You just have to mention that particular address and take a value.
Okay. Okay. Okay.
Hmm? Yeah.
Mhm.
Okay.
Yes, sir. Understood.
Yeah. Arvind, have we finished this?
Yeah, I wrote it.
Okay. I'll open the other program. Okay. I'll just open here. Okay. So this program is for I2C address finding. Okay. As like if you don't know how to find the address of each and every slave device you are connected to, or any device you are connected to, if you want to know the address, we'll be using this program. Okay. So we already know that your device is going to send an acknowledgement signal back, right? So that is what this frame format is. When you transfer your data to that particular device, that is that address. I'll show you this one. Okay, for example, if you transfer 30 and if 30 receives this, it will send an acknowledgement signal. Okay, if there is no 30 over there, it will not send any acknowledgement signal back. Right, that is a basic concept. Okay, whenever I'm calling your name, if you are there, you will respond. If you don't there, you will not respond. Okay, a same concept. If there is an address, it will send an acknowledgement signal. If there is no address, it will not send anything back. Okay, I'm just going to use that same thing over here. I'm just going to put in for loop from 0 to 127. Okay, each and every time I'm just transferring this particular I data. Okay, to this whether this I2C device is ready or not. If it is returning HAL OK, that means I'm just going to tell that particular address over here. If it is not HAL OK, I'm just going to make it wait. Okay, I'm just going to print some dot 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 something. Once it receives this HAL OK from that particular device address, that means this device address is communicating. Okay, so I'm just going to print that particular I value. For example, if it is 30, okay, from 0 to 29, it will print only the dot. At 30, it will just print this 30 in the UART. Okay, so now we know, okay, this device address is 0x30, something like that. Okay, so this is how we'll be transferring a data from our master or our device to any device to check whether this device is properly connected or not with that particular address. Okay, this is only for finding out the address. Okay, we are not transferring any data over here. We are just checking if the device is ready or not. Okay, is that code clear? A simple code. If it is not clear, just let me know. I will explain it again. Do I need to explain it again?
What is a 2, 10, sir? 10 might be timeout, but 2 size.
Which one? This is size. Number of bytes I'm going to transfer.
ஸோ அந்த அட்ரஸ் வாங்கி டைரக்டாக சென்ட் பண்ணிடலாம்ல சார் அதுலயே ஒரே கோடில்?
வாங்கி அனுப்புறதுனா அப்படி அனுப்பிச்சிக்கலாம். ஃபார் எக்ஸாம்பிள் இங்கே நம்ம இந்த அட்ரஸ் வாங்கிட்டு நெக்ஸ்ட் நம்ம முன்னாடி எழுதின ப்ரோக்ராம் அது கீழே அப்படியே எழுதிக்கலாம் அந்த அட்ரஸ் போட்டு.
சார் இங்க யூஆர்டி டிரான்ஸ்மிட் பண்றீங்களா? இந்த பஃபர் வேல்யூவை?
ஆமா. ஏன் டிரான்ஸ்மிட் பண்றீங்கன்னு கேக்குறீங்களா? இல்ல
அதான் யூஆர்டில டிரான்ஸ்மிட் ஆகுது. ஸோ இப்போ அந்த வேல்யூ வந்து
எனக்கு யூஆர்ட்ல எனக்கு டிஸ்பிளே ஆகிட்டே இருக்கும் கீழே. ஓகே, எனக்கு I2C வேல்யூ தான் தெரியாது இல்லையா? ஓகே, அதை கண்டுபிடிக்க நான் யூஆர்ட்ல பிரிண்ட் பண்ணிக்கிறேன்.
அதுதான் இப்போ இது இன்கேஸ் நான் இது பிரிண்ட் எனக்கு தேவையில்லை அப்படின்னா இப்போ நான் அந்த பஃபர் வேல்யூவை டைரக்டா நான் சென்ட் பண்ணலாம்.
பஃபர் டைரக்டா எடுத்துட்டு போயிட்டு அங்க I2Cல கொடுத்துக்கலாம்.
நீங்க இது ஜஸ்ட் அவங்க பாக்குறதுக்காக
நான் பாக்குறதுக்காக நான் யூஆர்ட்ல கொடுத்துருக்கேன்.
ஓ சரி, ஓகே ஓகே.
Finished? Okay. So this is the I2C for finding the address as well as for transferring the data either in a slave mode or in a master mode. Okay. So we still have two more topics. Okay, one is the CAN protocol. I'll explain what this CAN protocol, all these theory parts and everything, and then we will see the CAN protocol program. And the next one is we will have the bootloader. Okay, so there is something called as a bootloader concept. I'll explain what this bootloader is, and with that your device driver module will complete. Okay, so after that we will start this RTOS in that same board. Okay, whatever the board you're having, we will be just using the same like how this device driver polling method is converted into an RTOS, okay, real-time operating system. How to convert this particular board into a real-time hardware. Okay, that we will see in the next module once this two topic is finished. Okay. Yeah.
So do we have after this module like a kind of test or something or project?
We don't have a test. I'll give a project for you.
Okay.
Okay. I still, yeah. No test. Or if you need a test, I'll just give you the MCQ questions, which has both this pick as well as device driver. Okay. We'll see
Okay.
some, yeah, only MCQ questions, mostly related to this microcontroller, this communication protocol, timers, prescaler, something like that. We will see. Okay. And I just have to give you this project for C++, bare metal, and the device driver. Okay, 3 projects are pending. I'm yet to give that. So mostly I'll complete this module on let's say Thursday. Okay, most probably Friday I will give you these 3 projects. You can start working on that and finish it before this month. All these 3 projects. And still most of you haven't submitted this GitHub link. Okay. So Venkatesh, you haven't given the GitHub link.
Sir, I already told for help, need a help.
What happened?
Ask you GitHub, sir. Or I have an issue with the GitHub,
Okay.
and I asking for you to need help. GitHub not uploading
Oh, okay.
there.
Okay.
Okay.
Okay. Just
I contact you, but
okay. Just tell me on this Friday. Okay. We will just work out on that.
okay,
And yeah, Mohammed, you actually given this GitHub, but your project is not uploaded yet. Okay, it's still an empty GitHub, I think so.
Yes, sir.
Okay.
Actually, I'll do it.
So just do this one. And
Actually, I was having
Balasan,
issue with this laptop.
okay.
Yeah. So once I get time, then I'll do it.
Okay. I still have to put Yuvraj and Arvind over here. So Yuvraj and Arvind, you have already. Okay, Yuvraj, you have done the C++ project, right? I hope. No.
No, sir. I didn't get that project details.
Okay, no issues. You can just give this from C++, which I'll give on the Friday. Okay.
Okay,
So yeah. And Arvind, you are actually started this module on PIC, right?
Yes, sir.
Okay, so from pick you just have to submit this projects. Okay, in the GitHub link.
Okay, sir. I have a
Hmm?
link, but I'll share it tomorrow. Yeah.
Okay, okay. Yeah, okay. So I'll just give this one for C++, bare metal and divested.
So I will give you that link for you now.
Yeah, just create a repository like this.
No, I
Okay.
have already. I just give you that link.
Yeah, that's what I'm saying. Create a repository and then get. I don't want your GitHub. Okay, I just need this something like an embedded project. Create a repository and then give the link. Okay, put all your projects inside that particular repository. Something like an embedded project, and put all your projects inside that.
Okay.
Yeah. So
Sir?
just have to.
Yeah, bare metal and device driver both are different things or same thing?
Different.
How?
Okay, you're asking R module
Yes,
or in general?
in general.
In general, bare metal. Okay, even here in this device driver, we have written two different codes, right? One is HAL based code, and next one is in bare metal code.
Yeah.
Okay, so bare metal code is like you don't have any other APIs, you will be directly working with the registers.
Mhm.
Hmm?
Yeah, that I
But
understood. So,
ah,
like device driver, if we say means like both like bare metal and HAL both.
yeah, bare metal also you can say it is a device driver. You are written a device driver for the PIC microcontroller using this bare metal.
Okay.
Okay, so that is also device driver only. You are writing an driver program for the particular peripherals. That's it.
Okay. So now what we are doing is like bare metal with ARM, like that we could say.
Yeah, you can say.
Oh,
Yes. Hmm. Okay. So tomorrow we'll see this CAN protocol. Okay. Yeah. Thank you. Bye. We'll see you tomorrow.
thank you, sir. Bye.
Thank you. Bye.
Sir.
Hmm.
So GitHub I have some doubts. Can you
Okay.
step back?
Yeah. Okay. Share your screen.
இதுதான் கிரியேட் பண்ணிருக்கேன்.
ஒரு நிமிஷம். ஓகே. இது போதும். இந்த GitHub லிங்க் மட்டும் எனக்கு அனுப்பிச்சு விடுங்க. கீழே இருக்குல்ல.
அதுதான் அனுப்பிச்சேன் நான் ஃபர்ஸ்ட்.
அதான் அனுப்பிச்சிங்களா? அப்போ ஓகே. அப்போ ஓகே.
இப்போ இந்த ப்ராஜெக்ட்ஸ் இன்க்ளூட் பண்ணனும் எப்படி சார் இது?
இங்க கீழே கொடுத்துருக்காங்கல்ல இந்த கமெண்ட் லைன் கிரியேட் நியூ ப்ராஜெக்ட் ஃபார் கமெண்ட் லைன். நீங்க இந்த ஸ்டெப் ஃபாலோ பண்ணணும்.
இது எல்லாமேவா?
ஓகே. இங்க ஆட் வந்து readme.md அப்படின்னு இருக்கு இல்லையா? அதுக்கு பதிலா உங்களோட ஃபோல்டர் என்ன ஃபோல்டரோ அந்த ஃபோல்டர் நேம் கொடுத்துருக்கணும். ஓகே. git add அந்த ஃபோல்டர் நேம், அப்புறம் கமிட் மெயின், எங்க அப்லோட் பண்ண போறீங்க, எங்க புஷ் பண்ண போறீங்க, அவ்வளவுதான். அந்த ஆட் மட்டும் வேரி ஆகும்.
ஆக்சுவலா எங்க ஆபீஸ்ல இது யூஸ் பண்ணதே இல்ல. நாங்க வேற ஒரு ஷேர் ஃபோல்டர் மாதிரி தான் வச்சிருப்போம்.
You can use it git bash for this.
You can use a git bash. Yeah.
Git bash. Yeah, that software is very easy to handle. Go to that particular folder and you can use this all the.
Okay, sir.
It is like a GUI.
ஓகே டைரக்டா நம்ம இதுல யூஸ் பண்ற மாதிரி ஃபைல்ல
ஆமா.
அப்படியே போடுற மாதிரி
அதே
காப்பி
மாதிரி
பேஸ்ட் பண்ணலாம்.
வரும்.
பட் ஆனா நீ அந்த இப்போ ஃபார் எக்ஸாம்பிள் வந்து கோடிங் சேஞ்சஸ் எல்லாம் பண்ண இப்போ இதுல காட்டுற மாதிரி அதுல காட்ட முடியாதுல்ல.
புரியல.
ஃபார் எக்ஸாம்பிள் இப்போ ஃபர்ஸ்ட் ஒரு ப்ரோக்ராம் அடிச்சிருப்போம், நம்ம இதுல வந்து ஒரு 2 லைன்ஸ் சேஞ்ச் பண்ணிருக்கோம்னா அந்த மாதிரி நம்ம டைரக்டா போட்டா அதுல நம்ம தனியா
டைரக்டா
எடுத்து
அப்லோட்
பார்க்க
பண்ணா உங்களுக்கு அந்த வராது.
இந்த மாதிரி பண்ணாதான் வரும். ஓகேங்களா?
ஆமா, இந்த மாதிரி பண்ணாதான் உங்களால என்ன சேஞ்சஸ்ன்றதை பார்க்க முடியும். தட் இஸ் வெர்ஷன் கண்ட்ரோல். நீங்க டைரக்டா அப்லோட் பண்ணீங்கன்னா அதுல வெர்ஷன் கண்ட்ரோல் வராது.
பட் என்னோட பழைய இதுன்னு காட்டும்ல, வெர்ஷன் 1 2 3 அதுவுமே காட்டாதா?
காட்டாது.
ஓ ஓகே.
Changes cartoon நினைக்கிறேன். Like each changes will give the some
that
ID.
if you do
Yeah.
this in this commit and push, it will show. If you directly do this upload file, it won't show.
ஓகே சார்.
Yes.
தேங்க்யூ சார். நான் இதை
Thank
அனுப்பிச்சு
you.
விடுங்க.
Okay. If you have any doubts uploading this one, I'll just help you. Okay.
ஓகே சார்.
Okay. Thank you.
Sir,
தேங்க்யூ சார்.
tomorrow you can available. Tomorrow you will be available, sir. I want to guide purchase the STM board.
Yeah. Tomorrow.
Yes, sir.
Okay, we will see. Actually,
Yes, sir.
yeah. I'll just check and let you know. Okay.
Okay, sir.
Yes.
When time you can?
That I will message you because
Sure.
I need to go and check with the office, like if there is any meeting is scheduled tomorrow. If nothing is there, I will just let you know. We'll connect in the morning session.
Okay, sir. Okay.
Okay, sir.
Yeah.
Bye.
Thank you.
Okay. Bye.